welcome to all of you. There may be a few people drifting in late. So, why surfing the waves? This was inspired by the response to the initial work that we did for the EIEG last year, when the response from the Treasury, if I can be blunt, was somewhat underwhelming, and they decided they wanted some real economics done to prove how things were done. So they said, well, let's do some traditional economic modelling for growth. So they looked at, not unreasonably, the individual elements of the infrastructure, and they picked up co-location and sharing. So they said, oh, what happens if we run a power cable through the Channel Tunnel, etc. But they didn't look at, for me, modelling interdependency from either a performance, resilience, or economic perspective. So I sort of read the report from Frontier Economics and thought, could have been more exciting. So they looked at the economic benefits of this, but not these. And if we think, what are we going to do about that? We need a model that accepts and values interdependency. Economic modelling in straight lines, in linearity, just doesn't work anymore. And we also need to understand that time is an important element. Somebody decides to build a nuclear power station, it's 10 years. So it doesn't respect a budgetary cycle or indeed an electoral cycle. It's something that stands outside that. In 2009, the CST said the UK infrastructure is a network of networks, and I'm taking that as my base point. It's a network of networks. And arguably, it looks something like this, one of various diagrams that we came up with a bunch of elements: energy, transport, ICT, water, waste, at the primary level, and each depends to some degree on each of the others. So they're quite important. So might a model, because I'm not an economist, as you might gather, might a model that deals with interdependency provide us with some feedstock for thinking about economic modelling at a systemic level? So each element has what I believe they call in wind turbine terms an installed capability, an installed capacity. It can do this much work, and it has a level of productive activity, some work that it does. And I think wind farms, it's about 30% on a good day, but others are rather better. Heathrow, I believe, is 98% at the moment. So if we take activity and divide it by capability, we end up with a level of utilisation, and that's fine. What it also leaves us with is unrealised potential, other things that we might do, another runway at Heathrow, another generator in a power station, some other activities that we might add on. So we've got unrealised potential. That gives us latency in the entire system. Latency times utilisation gives us a measure of effectiveness. When we've used up the current capacity, we start to explore the potential. Perhaps increased activity without investment lets us generate a level of local growth simply by getting a bigger return on the investment that we've already made by exploiting the capacity we've got. And that's fine, and it sort of makes sense. So down here we get some activity going green, and that matches up to our capability, and then it starts to explore our potential, eats up our latency, and drives up our utilisation, overall our effectiveness. And I would call that, because I'm not an economist, an improved return on investment. We get better growth for our money. Okay. So we stimulate energy. That immediately demands extra on the ICT, because none of the energy systems now run without the ICT running at the same time, and that will stimulate transport to move fuels around. It'll draw water to keep the thing cool, and there'll be some inevitable waste product at the end that we have to dispose of. So by starting at one point, we can keep clicking the buttons and make the whole thing sort of come to life. So as we're stimulating one, all the others are running. We have to accept that. It's great, isn't it? Office 2010 animations, absolutely brilliant. When our current capability and potential is fully exploited, what happens? And in a mature economy like ours, I say, and failing or in need of replacement, don't mention sewers under London, 98% of utilisation at Heathrow, etc. It's actually too hard to make a straightforward economic case for replacement or upgrade. You sit down and do the business benefits, it just doesn't make sense, because you're saying all we're doing is replacing capacity we've already got with the same capacity in a new site. The payback is not great. Locally, costs too much and doesn't provide sufficient additional value. But perhaps the economic benefit of doing that rests in the enabling role of the particular bit of primary infrastructure that we're playing with, rather than anything else. Perhaps we can measure the benefit somewhere else in this network of networks, maybe in the secondary infrastructure, and perhaps And we get away from the economics a little bit here in societal rather than economic benefit. We think about the benefit to society. And do come in. I'll stop. Bristol does a spectacularly good line in Broken Biscuits, I've noticed. And if you want an academic reference to throw into it at this point, you could talk about Junichi Taguchi, for those of you who are quality experts, who talked about the loss imparted to society from the moment a product is shipped as a way of measuring value. Loss imparted to society. Really interesting. Okay, so we need to understand investment and growth in a systemic sense. For me, there's some waves at this point. Infrastructure investment works in waves over time. Wave 1, let's design and build something. Wave 2, let's maintain it. Wave 3, let's exploit it. So the first one lasts the life of the phase, 2 to 10 years to build a decent bit of infrastructure, or 15 if you're going to build high speed too. And it enables growth, but in itself perhaps adds little direct value, particularly if it's a replacement asset. But growth arises primarily at the location of the designers and builders. So if we buy our design from the French for our nuclear power stations, most of the economic benefit is going to arise in the case of vignerons and cheesemakers rather than anybody else. And it looks a bit like that. Random pictures selected from Google. We get a spot in the middle, and we get some small waves echoing away from that spot in the middle. Wave 2 also belongs to the infrastructure owner. It lasts the life of the element itself. That might be 5 years. It might be 100 years. More likely to be 50 to 100 years, particularly our friend John building bridges for the railways and that sort of thing. It supports and enables long-term economic growth locally and elsewhere. It starts to echo out into other sets of activities. And maintenance spend is also relatively local. And so our second wave, having designed and built and got a hump of investment, we then continue spending money in that area, maintaining the asset throughout its life. So there's a level of economic activity. If you ever watch, grew up like I did in a docks town, growing up in Southampton, at 4 o'clock you could watch all the people coming out of Fossperthorny Cross. They'd all sort of rush through the gate, all 4,000 of them, spending money in the local shops, buying their paper, buying their cigarettes, buying their sandwiches on the way to work in the morning, buying new cars, shopping at Woolworth, etc. There's a whole wave of economic activity that sits around an infrastructure asset. So it delivers some level of local benefit while also paying off the guys who built it. And that starts to look a bit like that. We get 2 waves, concentric circles starting to overlap and echo out. Wave 3 is a really interesting one because it's probably outside the scope of traditional economic analysis. It lasts the life of the primary element, and it's probably got multiple cycles. Yeah? We probably do several things with a piece of land adjacent to an infrastructure asset during the life of that asset itself. And it will have multiple exploiters, lots of different people who engage with it, who live off the back of the infrastructure investment. And when we do that, we have to look at measuring benefit in the exploiting infrastructure, not the primary infrastructure. It is purely there, maybe, as an enabler. And we can look at what I call the social infrastructure, education, commerce, civil administration, healthcare, and defence as being the next level up. And there's a little picture of a big wave down at the bottom, so I thought I'll put a big picture of a big wave on there. And for anybody from the northeast, that's apparently the North Tyne Lighthouse. Not one I personally recognise, but I do like the wave. So our base level looks a bit like this. We've got a diagram with many people will now be familiar with because they've seen it at various presentations that some of us have done. Energy, transport, ICT, water and waste all being connected as the primary infrastructure. Wave 1, let's build some. Wave 2, let's do something with it. So on top of that, we build health, education, commerce, defence, civil administration, all starting to exploit that primary infrastructure. And we've got an enabling activity and a dependent activity. And that, of course, creates wave 3, which is where society emerges at the top. And then again, I'm very pleased with my Office 2010 animations at this point. So we start by saying, let's have some energy, let's stimulate some energy in the system, and that will call the demand on the ICT, which will stimulate transport, water and waste. Yet again, we've seen that bit before. And let's assume lots of people on the building site, building an asset, they want their sandwiches, they want their breakfast, etc. So the first thing that will probably happen around that is some level of commercial activity, even if it's only to feed the workers. That will then stimulate health and education, defence and civil administration, all in that area. So we've now got, having provided some energy, we've got a whole bunch of people saying, I want some of that, I can use some of that. And then it starts to come to life. This will just run and run and run for as long as I let it. Okay? So you can see the whole system interacting together. Now, at some point you say, let's put a pin in the table and lock that and decide which bit to do first. And the answer is, well, in a sense, it doesn't matter. The whole system is operating now as a system. As we stimulate demand in one area, it pulls and draws through into other areas, and society sits on the top in a somewhat shaky fashion, not quite sure what's going on around itself. I'll do that again because I enjoy it so much. Doesn't matter, the starting point is completely arbitrary. You can go in there anyway and just click this off somewhere down here, and all the rest of it will flow from it. Okay. This is not an answer. It's the beginning of a decent question. My suggestion is that what we need to do is develop and adopt systemic economic models to synthesize and understand how to realize the potential of our infrastructure. The individual entities, of course, co-located and codependent entities, the gas power station at Grain that also has a plant that reheats cold gas coming in. It's free heat. Interdependent networks and networks of networks. We need to develop and test hypotheses in economic terms, but economic terms that respect the systemic nature of the entities that we're playing with, because we've been avoiding them for far too long, that looks at the notion of integrated investment by fragmented owners. If you go back to that diagram and say, where do you start? You actually need to start at a community level almost, rather than dealing with an individual organization. It needs to look at long-term intergenerational infrastructure investment. If something is going to last 100 years, let's start thinking about how we might measure the benefit over most of that 100 years, including, maybe these days, recycling it all at the end as part of the argument. And we need to look at how we can make this work in the context of short-term electoral and budget cycle thinking, because frankly, that's probably the biggest barrier to any of it. And that's the end.